Hi, I'm Bauman from On Semiconductor. Today, I'd like to talk to you about an innovative image sensor solution for automotive imaging applications. One of the most critical parameters in an automotive imaging environment is dynamic range. This is because in an automotive application, you typically have very bright signals and very dark signals that you're trying to capture at the same time. For example, when you're entering a tunnel and you need to capture what's inside the tunnel at the same time as capturing the color of the sky. Another issue that in automotive imaging we deal with is that you have to capture pulsed light sources, which are increasingly used for automotive lighting, such as in headlights, taillights, and traffic signs. These light sources are actually pulsing, however, our eyes do not see that. So when you capture them with a camera, you're likely to capture these lights at a time when they're actually off. So this can also lead to problems for front cameras, which are used for features such as automatic emergency braking, traffic sign recognition, and so forth, where if the pulsed LEDs are not captured in one frame, then the algorithms may not be able to make the correct decision. One way to guarantee that pulsed light sources are not missed and you don't get the appearance of flicker is to capture LED pulse in every frame. One way to do this is to constrain the minimum exposure time of the image sensor to capture the minimum frequency of LED lighting that you expect to have in the scene. The problem with this is that with a limited dynamic range in a single capture, when you increase the exposure time, you're going to blow out the bright areas of a scene. At On Semiconductor, with the introduction of the AR0233, we have a solution that enables capturing high dynamic range signals while simultaneously mitigating the problem of LED flicker. So here we have a test setup inside our light box to emulate a high dynamic range scene. We also have an LED test board that we're using to drive these LEDs to be pulsing at 100 Hertz with 10% duty cycle to emulate what you'd see in an automotive lighting environment. And we have the AR0233 Mars board connected to our evaluation system. And we're showing the output of that compared to what you would see with a traditional image sensor solution that we're using this camera phone to capture. So with a normal image sensor, like you have on this camera phone, you can only capture a certain amount of dynamic range. So either you can capture the bright areas here and you have a short exposure time so you see this LED flicker effect, or you can actually set it so that it increases the exposure time and captures the LED pulses, but now you have a saturated bright area as you see here where you're not able to capture the filament in the light bulb. With the AR0233 solution, we're able to capture the pulsed LED light sources and they show as being on, while at the same time getting the detail in the bright areas. That's how we enable simultaneous high dynamic range plus LED flicker. Thank you for your time. For more information about the AR0233 or any of On Semiconductor's vast portfolio of image sensor products, please visit www.onsemi.com or contact your local sales representative or distribution partner.